In chapter 3, we introduced the idea of transformations, and we discovered that there were three types of transformations that we call congruence transformations. And whenever we subject a polygon to one of these three transformations, we end up getting a congruent polygon. So if I look at this, there's a original equation that we're given, triangle ABC, and then we're told what the coordinates of those are. And then notice that in the subsequent parts, part A, B, and C, they keep asking us to go back to the original triangle ABC, go back to ABC, go back to ABC. So in this problem, we're going to keep referring to the original triangle, and we're going to keep doing different things to that. On some tests and some questions in the book, they did the thing where we started with a triangle, transform that, and then we would transform that resulting shape. But you can see I'm not telling you to do something with A prime, B prime, C prime right here. I'm telling you to do something with A, B, C. So we're going to keep going back to the original triangle. So probably an important first step would be to make sure that we correctly plot our original triangle. So I guess I'll use blue for that. And point A is at negative 7, 3, so I'll go back 7 and up to 3. So this is A, and it's at the point 7, comma 3. The next point that I see here is B, which is at negative 6 and negative 2. Kind of ran out of room there. Let me put the coordinates for A somewhere else. A is at 7, comma negative 7, comma 3. B was at negative 6, positive 2. So here's B at negative 6, 2. And then finally we've got C that lives at negative 4, positive 4. So as I look at this triangle, right, and I guess I'll sketch it. Here's the triangle. I'm going to keep referring to this triangle that I've written down in blue, and we're going to use it. We're going to subject it to some different transformations. The first transformation we're going to subject it to is a reflection, and it does say a reflection across the x-axis. So remember our axes, this is the x and this is y. So I'm going to reflect across x. And as I do this, I want you to notice as I do this reflection across the x-axis, what's changing are the sign of the y values. So for example, point A was at negative 7, 3. Well, A prime is going to be at negative 7, but then negative 3. So this is where A prime lives. It's at negative 7, negative 3. What happened was the y value changed signs. For B, B was at negative 6, 2. It's going to go to negative 6 and then negative 2. So here's B prime. It's at negative 6, comma, negative 2. And then my final point, C, is going to go to negative 4, negative 4. So here's C prime at negative 4, negative 4. And you can see I keep writing down the coordinates of A prime in inconvenient spots. So this is the triangle that I get if I reflect across the x-axis. Now I could have reflected across the y-axis. They didn't ask me to do that. And I could also reflect across some other line, right? If they gave me some other line, I could reflect across that. But I do notice, what's happening here. All of these coordinates, right? If you look at this 4 becomes a negative 4. This 2 becomes a negative 2. This 3 became a negative 3. And if you were to reflect across the y-axis, something similar happens, but not the y-coordinate that changes. So I think you could think about that and come up with the rule. The next thing we're going to do again is we're going to take our original shape, and this time instead of reflecting, they're asking us to rotate it 180 degrees around the origin. So as we saw in class when we did this together, right, if we're rotating rather, if it's 180 degrees, we don't need to know if it's clockwise or counterclockwise, because we saw that if we go 180 one way, that's the same thing as going 180 the other direction, right? You still have it at the same spot. So I'm going to take this shape and rotate it through 180 degrees. And if you've done this with patty paper, right, one of the things that perhaps you observed is that the coordinates end up just going to the opposite coordinate. So if I'm at negative 4, positive 4, I end up going to 4, negative 4. So this point right here We're calling this C double prime because it's the second transformation we've made, but it's really just one transformation of this triangle, this rotation. But notice the coordinates of this now. They're at positive 4, comma, negative 4. So in other words, the values of C that I had became opposites. Instead of negative 4, 4, it became 4, negative 4. So there's C prime. Let's do the same thing with, I should have probably done A and B first. Let's do A next. A is going to go to 7 and then negative 3. And B should be going to 6 and then negative 2. And you can see I've totally written down the correct coordinate for C, but I'm not at negative 4, am I? I'm sitting at negative 3. So those of you that are watching this and like, hey, Roberts, it's the wrong spot. Yeah, this is supposed to be negative 4, not negative 3. So here's my C. I'm calling it C double prime. Here is my A, and here's my B. And I'll go ahead and sketch this triangle. So that's what I end up with if I do a rotation. And again, you know, patty paper is always available. If you want, you can plot those and take a look at where they're going. But try to notice what's happening with the coordinates. In this case, what's happening is we're just taking the opposite. So this negative 6 becomes a positive 6, negative 2. And A is going to go to positive 7 and then negative 3. The final transformation that we have to do is a translation. And a translation is just where we slide around either left or right. And if you look at this translation rule, what it's saying is that if you take an xy point, we're going to increase the x value by 5, right? We're adding 5 to what x is, and we're going to decrease the y value by 1. So it's a pretty straightforward rule, right? Increase x by 5, decrease y by 1. And again, we're starting with the original triangle, triangle ABC. That's what it says, start with the ABC. So when I do that this time, I guess I'll use the black ink. So for A, I'm going to go over 5. So there's me going 1, 2, 3, 4, 5, and then I'm going to go down 1. So this point right here is my new A, and I'll call this A triple prime. Let's do the same thing with B. I'm going to go over 1, 2, 3, 4, 5, and then down 1. And when I go down 1 right there, I'm now at my new B, and this is B triple prime. And then the same thing with C. I'm going to go over 1, 2, 3, 4, 5, and then down 1. And I am ending up right here at C triple prime. So here's my new triangle. And I'm going to go ahead and erase these lines, the over 5, down 1. And again, why am I going to the right 5 and down 1? Because it says you're going to increase x by 5 and decrease y by 1. So I'm just following that rule. So let me go ahead and erase this, and I don't need this now. And I'll just go ahead and sketch in the triangle. And for this one, I should go ahead and write down their coordinates, right? C is at 1, comma 3. B looks like it is at negative 1, 1. And A is at negative 2, comma 2. Negative 2, 2. So those are all of the transformations we were asked to do. We were asked to do a reflection. That's the one in red, a rotation of 180, that's the one in green, and a translate, adding 5 to x and decreasing y by 1. And then the other thing we're asked to do here is identify the coordinates of these points. So if I look at this, I can see that C prime is at negative 4, 4, so I'll just write that there, negative 4, negative 4 rather. B, the double prime one, is at positive 6 and negative 2. And then finally, A triple prime ended up at negative 2 for x and 2 for y. So those are the coordinates after I perform these translations. They're congruence, transformations. They're congruence transformations, a reflection, a rotation, and a translation.